Hello YouTube. Today I have a second book review, and this time it's a little bit more about popular books on physics. So not books you would need for university courses, and books which are more enjoyable for non-physicist audience, let's say. The first book is, and also the second book, is from Stephen Hawking, Universe in a Nutshell, and also the Short History of Time in a more modern edition here. And they are nice books, but for me it was not so enjoyable to read them. Stephen Hawking was an extraordinary physicist. He discovered a couple of things about black holes and was quite prolific in this area, but he is not a new Einstein or something like this. And these books, they're okay, but and for beginners it's nice introduction, for example, to ideas of relativity, the ideas of relativities or quantum physics. But for if you study that subject, it's not so much new material. And then he starts to introduce his own concepts like imaginary time, which is a concept which is not so widespread in the physics community. Let's say even the people who are working actively in this field of field theories, unified field theories, I think not everybody is familiar with this concept of imaginary time, because it was very much his thing. And he, in one of his books, he's starting in the middle of the book with the concept, and you get the impression that that's actually the direction which modern research is going, but that's not the case. So they are a bit biased, but it's nicely illustrated. But for me, it was not so enjoyable to read them. It's the first couple of books. The second book is from also an English author. It's also a classic book from Roger Penrose, Road to Reality. And he starts from beginning and ends with the ending, let's say. And yeah, I don't know if you're familiar with this series, the Big Bang Theory. At some point, Kelly is a little bit worried about being stupid, and she doesn't know anything about physics, and then she asks Sheldon to explain physics to her. And he starts with ancient Greek, and this is how this book starts. So it starts really from ancient Greek and the concept of science and numbers, and after 400 pages you start with special relativity and the space-time, and then you go to particle physics and stuff like this. So you cover a lot of mathematics, also a lot of exciting mathematical concepts. But at some point I have to say that if you are not familiar with mathematics, I mean, then you get some benefit from the first couple of pages where he explains numbers and maybe your differentiation, and you had that in school and you remember stuff like this, and the exponential function or so. But later his concepts are getting I mean, he gets to Riemann surfaces and complex mappings and hypercomplex manifolds, symmetry groups in the first 400 pages. And at some point, I think non-specialist or somebody who with not a university background is getting lost. So then the last 600 pages, it says about 1,100 pages or so. Last 600 pages are then on physics. And in the end also he's a little bit biased. He is putting his twistor theory quite in front at the very last two chapters, let's say. But to be fair, he is also presenting quantum gravitation and string theory in a nice way. So altogether it's not a bad book, but it took me about, I think, 1.5 years to read it, because sometimes I fell asleep after reading 1.5 pages. Yeah, I mean, Roger Penrose is really a genius. He did not only make contributions to physics, fundamental contributions to physics. He worked together with Hawkins, for example. I think he was the doctor father. He is the doctor father of Hawkins. He's still living. He's 95 or 96 now. And but he also did a lot of really groundbreaking research in mathematics, in different fields of mathematics. For example, in pattern theory. So pattern theory is in principle a theory how you can tile a floor with certain types of tiles. And there's a Penrose tiling, which is, if I recall it correctly, it's a non-repetitive tiling that tiles an infinite big floor space with a non-repetitive pattern. So each point on this floor space is quite unique. Next book is it's actually 2 books. It's from Emilio Segre, if I pronounce it correctly. This is an Italian physicist who made a lot of important experimental contributions to nuclear physics and atomic physics. And he wrote a book about the history of physics, and it's actually 2 volumes that is here covered in thick volume, 800 pages or so. And he's starting with, I think, Huygens. It's 25 years ago since I read that book. Huygens and Newton, Galileo. And the second part starts with Becquerel and Curie's discovery of radioactivity and all the modern physics. So, and he is, and these are little biographies of all these physicists and all their contributions to physics. It's a really nice book. It was a really enjoyable reading. That's really good written. So the next part is a biography on Werner Heisenberg. He wrote that book. It's an autobiography. And Werner Heisenberg was a very prolific and important physicist of the first half of the 20th century. He is one of the fathers of quantum mechanics, together with Dirac and Schrödinger and Pauli. What makes it interesting that he, during the Second World War, he was working on the German uranium project, so he was trying to build an atomic reactor. There are speculations if he was involved in an atomic bomb project. His historians and also physicists, and also I don't believe that there was no such activity running in Germany, but there are also opposite views about this topic. But this is an autobiography. I think the time from 1933 to 1945, this autobiography is also a little bit biased, of course. I think it was written in the 60s, but it's a very nice book, and it describes very nicely the beginnings of quantum mechanics and what was going on in the Munich school at that time in Göttingen. It's a very nice book. The last book, it's really, I've read that book 5 or 6 times. It's the German version of Surely You're Joking, Mr. Feynman, from Richard P. Feynman. It's also a kind of biography and anecdotes. And Feynman is a really unique person, and these anecdotes are immensely funny. So Feynman was one of the important physicists of the second half of the 20th century, and he invented path integral formalism in quantum mechanics. So that's one of his contributions. Then he invented, together with Julian Schwinger, quantum electrodynamics, so the first complete field theory in quantum mechanics, let's say. And he also did some great research on superfluids and superconductivity, I think. But I think he's known for these books. And there's also a lecture series which I will present in a couple of weeks here on this channel from Feynman. But to the public, he's maybe best known because he was involved in the task force team that was established after the Challenger explosion in 1986. And he made some major contributions to clarify the roots why this explosion could happen. And I think he made it was his style. He during a TV conference, he put some of the seals of the rocket fuel tanks into ice water and showed the press how these rings got lost their flexibility and broke off actually. And that was basically the solution to the problem. Here, these anecdotes they're immensely funny, and it's very enjoyable book. It's not about physics; it's more about the guy Feynman. And yeah, he was also involved in the atomic bomb project, American atomic bomb project. So he lived in Los Alamos for a couple of years, and it's a nice book. Definitely enjoyed reading it. So at that point, I want to mention that all the books I'm presenting here I bought by myself, so that it's not an advertisement, or so it's just my own opinion on these books. Yeah, and also this channel will not only be about books, it would be a little bit boring. We'll talk a little bit about physics and mathematics, and also we will talk a little bit about other hobbies I have during the next couple of months. So if you liked this video, please hit the button as you don't want to miss the future content. See you. Goodbye.